Hello, ladies and gentlemen, and what we're looking at here is taking up solutions to our last test. Time is getting away from us, so I think I'd like to get them up and on the LMS so that everyone can see them. So let's take a look at the first question. It says, for each of the given series, use the formula taught in class to find T sub n. So we have a series here. The first thing we need to know is whether or not it's an arithmetic or a geometric series. Taking a look at it, I'm going to make a guess that it's arithmetic to start off with. So 7 minus 2 is 5. So if I add 5 to this, I get to 7. If I add 5 to that, do I get to 12? And lo and behold, I do. For all intents and purposes, I'm going to assume that this is an arithmetic series. Okay, so if it's an arithmetic series, that means that it has a formula for its T sub n term. That formula is a plus n minus 1 d. If you use the wrong formula here, everything will fall apart. In this case, we know that a equals 2, and the difference is plus 5. So T sub n will simply be 2 plus n minus 1 times 5. Now that's certainly an answer. It's not a simplified expression. To make it a simplified expression, we're going to do expand this 5n and simply get 5n minus 3. And that is your final simplified answer for number 1. 3 marks. Now the next question that we have here, was a bit of a typo for the test, so we learned that what we wanted to do was just determine S12. We had taken that off on the test day in class, and all we wanted to do is determine the value of S12. Now to do that, we need to figure out what type of sequence this is, what type of series. So taking a look at it, I'm going to make a guess. I'm going to take 3. I'm going to say if I multiply 2 by negative 3, I'll get negative 6. So if I multiply by negative 3, then if I multiply by negative 3 again, then if I multiply by negative 3, it seems to be working out quite nicely. So this is geometric. Geometric has a particular formula for figuring out the sum. That formula is S of n equals a r to the n minus 1 all over top of r minus 1. So what do we know? We know that we want the sum up to 12 terms, so n is going to be 12. We know that a value is our beginning value, which is 2, and you know that r is your common ratio, which is negative 3. Plugging in what we've got, you're going to get S of 12 equals 2 bracket negative 3 to the 12 minus 1 n bracket all over top of negative 3 minus 1. Now there's where you might make a mistake. You might not change that to a negative 3. Make sure you do. The final answer here is going to be, and that's worth 3 marks. Okay, so this was the formula that you needed. If you use the wrong formula, everything falls apart. If you don't know that it's geometric, you're in trouble. So here's the next question. How many terms are there in this sequence? So they start off and then they give you the last term. They want to know how many terms are there. Well, looking right off the bat, you know that the first term is 3. The question is whether or not it's arithmetic or geometric. If I multiply by 2, I get 6. If I multiply by 2, I get 12. That's looking pretty good for geometric. Let's try arithmetic. If 3 plus 3 gives me 6, 6 plus 3 does not give me 12. So geometric seems to make a lot more sense. We're going to multiply by 2. So we're looking at a geometric, with the common ratio being 2. All right, so there is a formula for T sub n of a geometric. It's a r n to the minus 1. Use the wrong formula, everything else is going to be wrong. Now, what we're really asking is what term this is. So the question becomes 1536 equals 3, 2 to the n minus 1. And our question is, what is that n term? So this is a exponential equation. We divide both sides by 3 first. We come up with 512. We still have an exponential equation. We want our basis to be the same. So we want 2 to the something to be 512. I'm going to make a guess at 9. And I was right. I should play the lottery. Notice that the bases are the same. The whole thing is equal. That means that the exponents must equal. And therefore, n equals 10. And what that means is 1536 is the nth term of this sequence. So if I kept going, so there was 10 of them, there would 10, and the last one would be 1536. That's it for now, and we'll do the second page in a minute.